All right, thanks for the intro. So, good afternoon. How are you enjoying the conference so far? Yeah, good, good. I'm actually a little bit blown away, to be honest. It's very hard for me to believe that this conference is in its second year, and harder still to believe it's from a town of only 150,000 inhabitants. So, I just want to take a moment to give a quick round of applause to the organisers because I really think that this is above and beyond. Very, very lucky. All right, so my name's Adele Carpenter. I'm a software engineer at Trifork Amsterdam. Most of my day is spent building and maintaining Java and Kotlin applications for the educational sector. Now, has anyone here seen a talk from me previously? Oh, a couple of hands. Wow, always so surprised when that happens. It never stops being surprising. But if you haven't seen me before, that's fine. I'm a relative newcomer. And for those that have seen me, welcome back. And thank you so much for supporting me. And thanks to everyone in this room for choosing to attend this session. I do hope that you enjoy listening to it as much as I enjoyed writing it. So I have spoken before about rewrites, and I use the example of Lika, a junior engineer who has just joined a team working on a large and aging Java project. And she's feeling overwhelmed at the sheer enormity and complexity of the project and feels that the only way out of her current nightmare is a rewrite or a port. But luckily, she's surrounded by an awesome team, and they help her see that a rewrite is rarely a good choice. As a team, they decide that they're going to move the project forward by taking small, consistent steps in the desired direction. And I 100% stand by that talk and that advice, but it did get me thinking, is there ever a moment when a rewrite is a good idea? And it turns out that this was a little bit serendipitous because around the time I was starting to think about this, my team and I were presented with this very question on a customer project. So to give you a little bit of background on Trifork, we are a project-based consultancy. So the team that I work with are a little bit unique in that we have a product as well, actually a suite of products that fall under our Accessible brand. The customer that I work for focuses on the Swiss education system, but we also support other assessment use cases, such as the driver theory exams in the Netherlands and in Denmark. Now, one of the products in our suite is the assessment delivery engine, or the exam player, which we deliver to our customers, each of which have a custom implementation on top of the core product. So basically, it can pass assessments that comply with a certain specification and then play the assessment for the student or candidate. So it renders the question, manages the time remaining, selects the next question, and calculates the result. So we have the product part, and the custom implementations are the project part. Now, recently, one of our customers, the one with the most custom of the custom implementations, was starting to get a little bit frustrated. And to be honest, we shared their frustration. So I mentioned that one of the features of our product is that it selects the next question. And that seems pretty straightforward, right? You have a list of questions and you pick the next one. You go from index 2 in a list to index 3. Well, no, not in all cases at least. We're developers, we like to complicate things. So for this customer, we actually have a dedicated web service for selecting the next question. And at the core of the web service is an open source C++ service written by a top researcher in the field of automated or computer-based student assessments. Now, her profile actually says automated testing, but I think for this audience, such language is a one-way ticket to a misunderstanding. And so the service she wrote is an implementation of item response theory. Now, item response theory is a family of mathematical models in psychometrics, which is the science of educational and psychological assessment. And the models of IRT are used to design, analyze, validate, and score assessments. Now, to make things a little bit more concrete, you can think of an item as a question of a certain difficulty, ranging from low to high. And then, as you would expect, an assessment is made up of a selection of these items. And the point of the assessment is to determine the student's knowledge of or ability related to the topic of the assessment. Now, in a standard assessment, everybody gets the same questions. And for the average student, some of the questions will be way too easy, and then for other students, some of them will just be way too hard, which makes the assessment kind of useless for them. So one of the cool applications of IRT is that you can estimate the student's ability or knowledge on the fly and then deliver a question that is at the right difficulty for them at that moment in that assessment. And this can make the results of the assessment more meaningful. And it also makes the assessment appropriately challenging and hopefully more interesting for the student. I mean, as interesting as taking a test could be. Now, I want to make clear at this point that this C++ service wasn't bad. The researcher that wrote it will forget more about IRT and statistical validation methods than I will ever know. But we did have some problems running it and maintaining it because the service, while it was reliable and fast, it was essentially a black box. Now, we sent it data and it said data back, and we didn't have the skills in our team to verify the results. We kind of just trusted that it worked and selected an appropriate next question for the student. Now, initially there had been some testing and validation done, but this was done by an external third party. So adding features to this service was just something we didn't do for just the fear that we would ruin the underlying algorithms or ruin their validity. And this was a key source of frustration for the customer, that while the service was useful, it was relatively stagnant. Of course, in a pinch, we could contact the researcher that built the app, but she's a busy woman and maintaining this service is just not her highest priority. Now, adding to this, the service itself was actually not a web service. Years ago, there was a developer on the team keen enough to write a wrapper around the algorithmic core. So we did have 4 endpoints that we could call. But our only options if we got an error was to simply just check our requests and retry. Now, further to this, logging in the core model was non-existent. So, for example, if we had an item with an unexpected difficulty, which could have been as simple as a typo, there was no logging to tell us what was wrong. And since our core model primarily dealt with integer arrays, in order to build the request, we had to translate all of our item data into those arrays, leaving our requests essentially meaningless. So it was just completely opaque to us. So if there were any issues then with a particular item, it was just almost impossible to figure that out. And some of our item banks are like 40,000 questions. It's a lot. And because this service is stateless, we actually need to send the entire item bank on every single request. So that's about 60,000 lines of JSON in some cases. Now, if you were brave enough and you did decide to open the code base, you were presented with code that was written in the language of the academic domain. So we had names like this. And let's just go through them quickly, all right? So we have a par. I mean, that's not too hard, a parameter. But what does that mean? Item difficulty, obviously. Now, we have b par, b parameter, okay. But in real terms, that's item discrimination. So how well does this item help us estimate the student's ability? We have cur-seg, current segment. Not too bad, still not explicit enough for my liking. And theta, another one from academia. Theta is the ability of the student, so the thing we're actually trying to estimate. And now that we know theta, can you yell out your best guess for warm theta? Nice try. It's actually called warm theta because Warm was the last name of the guy that proposed this method of estimation in a paper. Not because it's a close guess, although, you know, it actually is kind of a close estimation, so it sort of works. And then we round out the list with cluster and category. Again, academic terms. In the team, we use the words friends group and domain, respectively. So I hope I have made it pretty clear at this point why the current service is problematic. So it's a black box, it's hard to reason about and debug, and trivial changes take a long time and include a steep learning curve. And maybe not so obvious is what makes the service a good candidate for a rewrite. Does anyone have any ideas? No? Oh yeah, yell it out, it's fine. Right, I would put that in why it's problematic, not on what makes it a good candidate for a rewrite, but yeah, absolutely, that was why we were looking at rewriting it. So what makes it a good candidate for a rewrite though, is that it's stateless. So it receives data and it returns data, so we don't have to worry about a data layer or a front end. It has a well-defined scope or footprint, so we need to expose 4 endpoints to one service only, and it is a small part of the entire project. So this means that it reduces the risks or potential downsides of a rewrite attempt. Now, this brings us to what, in my opinion, are the 3 most compelling reasons to entertain the idea of a rewrite. So personally, I think you need all 3, but you would want at least 2. And the reason that I would want all 3 is because they each look at the question of should we rewrite from a different perspective. But first, I actually want to start with a reason 0, because we're developers, so we are 0 indexed by design, but also because without reason 0, then the other reasons are actually irrelevant, which is, reason 0, there is a desire to functionally change the application. So if an application is running reliably in production and there is no desire to change its functionality, I would be hard-pressed to come up with a reason on why you would rewrite it. You might see some odd behaviour here and there, and investigating that when it happens is the bane of your existence for a day or 2. But if those incidents are few and far between and there's no desire to change the functionality of the app, then that is probably just a reasonable cost of running it in production. Because as long as you can do the bare minimum to keeping it running, like bumping versions when necessary, using long-term support versions wherever possible, the status quo is probably fine. And if this is the case, and you still want to rewrite or port your application, you need to dig down a few layers on why you would want to do that. Because it's probably about you, and it's not about the project at all. So, for example, you're just not comfortable being responsible for something that you don't understand well, although in this age of vibe coding, we might be more and more comfortable with that. So, on to the first reason why you might entertain the idea of a rewrite. And we're going to start looking at the current service as it is in the context of the team responsible for it. There are no small steps to be found. Now, I stated already that I 100% stand by the advice to focus on consistency over perfection, to take small steps to evolve your application. And there's a big implication here, though, which is that the small steps are in fact small. So let's take the example of bad logging in my Teams project that I mentioned earlier, because a great quick win would be to add some logging, right? Now, in this case, given that we are a JVM-based team working on a C++ service, that would require running the project locally, learning how C++ works, actually learning about a lot of stuff that the JVM abstracts away, like memory pointers, identify an appropriate library, add the dependency, learn how dependency works in C++, learn the basics of the build tool, and then pray that it runs again. Now, for some teams, maybe adding logging to this application is indeed a trivial change. But for a team that lives mostly on the JVM, you need to ask, is the steep learning curve worth it? And at what point does something move from being a small step to being a large undertaking? And I also think it's a little bit simplistic to say that adding logging is always a small step. And the same thing goes for other small steps like improving test coverage, renaming, extracting methods, and improving abstractions. Whether they are really small or not is up for your team and you to decide. It's not up to me or anybody else. But what I can do, though, is offer some advice on how you might approach these discussions. And that is to be aware of your bias and to look for evidence that proves yourself wrong, rather than having a wish and then trying to prove that it's a good idea, which is our temptation, right? So this will help you minimize the impact of confirmation bias in your decision making. So For example, if you are currently feeling the pain of a legacy code base, you're probably biased towards rewriting the application in a way that is more familiar to you. Now, in this case, I would advise you to look for reasons to keep running the current application in production and look for reasons why that is actually a good idea. So you ask yourself questions like, why should I keep the existing code base, and what opportunities exist to improve it? Now, in our case, being the skeptical Dutchies that we are, we were the opposite. We actually saw a rewrite as an absolute last resort, didn't want to do it. So our line of questioning was more around what are the pain that we're experiencing now that can only be resolved by rewriting the application, and are the opportunities to improve the application actually there? And how much work are they really? And is that actually really less work than a full rewrite given the current makeup of the team? And this brings me on to reason 2 on why you might consider a rewrite, which looks at the team in the context of the organization. The skills are not in the team, and you do not wish to acquire them. Now, does the team have the skills to consistently improve the service? And if not, does the company wish to acquire those skills? Now, we have already established that one small step for one team could be a big step for another team. So you could be forgiven in thinking that this reason is basically the same as the first, but the key difference here is in the last part of the sentence, and that's what I really, really want to focus on here. No wish to acquire the required skills. So this is about maintaining applications that are in line with your company or project's tech stack. And this is a completely valid reason to consider rewriting or porting an application. And it certainly was a big reason for us, because at Trifork Amsterdam, when it comes to the back end, we are very much a Java Spring shop. And yes, that includes Kotlin as well. So we incorporate tools and technologies that are within that ecosystem, or at least closely related. Now, of course, we are made up of individuals with different backgrounds, so there is some .NET experience, some sane folk. And if you do go wise enough and grey enough, you will get some C++ experience. But our bread and butter is Java Spring, and that is not going to change for the foreseeable period. Because we're a small company and we actually run many of the applications that we build. So keeping our tech stack manageable is a strategic advantage for us. Now, that doesn't mean that every new service we write is in Java, especially if startup time, memory use, or application size are priorities. But it means that while we do believe in the right tool for the job, we also know who we are and what our strengths are. And we look for good enough tooling that is complementary to our existing tech stack. And I'm digressing a little bit here, but this also helps us avoid the pitfalls of resume-driven development, because considering a rewrite is a time where you can see RDD really come out in full force if you're not very, very careful. Now, as the name suggests, resume-driven development is making design and tooling decisions with the primary goal of adding content to your resume. And it often manifests as wanting to play around with the newest tech, even if that technology is completely incongruent with the rest of the project or the company's stack. So if you're considering a rewrite and your eyes light up at the possibility of doing something completely new with an unfamiliar but exciting technology, then that's just a moment to take a minute to ask yourself, do I really need a rewrite, or do I just want a playground for new toys? Or, to keep the analogy going, a kitchen for new desserts. So by now we've looked at the service in the context of the team, and we've looked at the team in the context of the organization. So that brings us to looking at now the service in the context of the entire application. The service is small and the scope is well defined, or it can be broken up in such a way that this is true. So earlier, we considered whether the opportunities to improve the code base as it is really there and do exist. But here, we are looking at the suitability of rewriting the application as deployable chunks. Now, this is all about minimizing the risk of wasting resources, building something that never sees the light of day. Now, in our case, our rewrite candidate was actually pretty well defined. It was a stateless service that had a very small, albeit important, role in the context of the application. However, we still ended up with 3 deployable chunks. This absolutely was not a 3-2-1 Big Bang cutover. And if the application you want to rewrite is larger and more central to your system, then it's even more crucial to have a plan on how you will break up the rewrite candidate into smaller deployable chunks. Having a small and well-defined scope for the rewrite is crucial so that you can see benefits of your rewrite as soon as possible. Because among other things, this reduces the risk of your project sponsors, pulling the plug on the project. So, back in 2004, Martin Fowler was the first to coin the phrase strangler application. And as an Australian, I actually find this really cool, as Fowler was inspired for this metaphor during a trip to Australia where he encountered the strangler figs. So that's at the front right of this photo here. So strangler figs are a parasitic plant that seed in the upper branches of a tree, and they eventually make their way down to the soil. So in this process, they envelop the host tree, essentially strangling it, after which the fig remains in its spectacular glory. And a strangler fig application works in much the same way. So this image is based on one from Paul Hammett's blog, which is conveniently linked to from Fowler's original article. Paul is an ex-thought worker, contributor to Selenium, strong voice in trunk-based development, and branch by abstraction. But before we discuss the image, here is the QR code to Fowler's original article, which you can take a picture of while I take a sip of water. So Paul's blog also links to a couple of handy resources as well, including an excellent paper by Chris Stevenson and Andy Pulse. So the rabbit hole that you can go down from Fowler's original article is actually really well worth it. So we're back now to the image, and this shows a very simplified evolution of a strangler fig application. So while harder in practice than in theory, essentially, you rewrite a small piece of the application and you run the rewrite alongside the original app. And slowly over time, as you rewrite more and more of the app, all traffic gets routed to the new application. And taking this approach makes it possible to weave in and deliver new functionality as you go, which can really help keep the stakeholders happy and build trust in the project. And as an extension of that, you can keep the rewrite project alive. Now, how you go about carving out a piece of your application to rewrite will depend on a lot of factors, and it might be tricky to know exactly where to start, but this is where you can use a handy concept from extreme programming called a spike. So essentially, a spike is an experiment to explore a possible solution to a new problem. And it's so called as a spike because it's end-to-end, but very thin. And a spike can be functional or technical, but usually it's best to start with a functional spike. So, you identify a pain point for your users in the current application, and you build a proof of concept to tackle that pain point. Now, ideally, you would get that pain point from users directly, and it's like bonus 1 million points if you do. But it's also just a sound approach to have someone in your team act as a customer proxy. Now, in our case, our first users were the researchers at the customer, and together we decided that the first deployable chunk would be a number of APIs so that it would be possible to interact with early versions of the item selection models. Now, the final application would actually combine 3 internal steps into one endpoint, but exposing the internals like this meant that the researchers could query the model directly, run simulations, and verify that the model did what they expected it to do. And if it didn't, they could provide feedback, early feedback. And delivering this value early, even though it wasn't production ready, this was important in building trust and keeping the project going with the full support of the key stakeholders. And further, it provided us with in-value information on how to get our first chunk to production and what the scope of that chunk would be. So, when the question came up in my team of, do we dare to rewrite, despite our strong bias towards not rewriting, when we considered these 4 reasons, the answer actually became pretty clear. And I am happy to report that we have, in fact, decommissioned the last instances running the old application, and we are 100% running the rewritten application in production. And not every rewrite project ends up in this position, and I have no reservations in saying that I'm proud of my team at Trifork for getting to this point. And I think it is a really cool milestone. So I'm going to share with you a little bit more about how we approached the project and what we learnt along the way. So the first step was to actually do an audit of what the current model actually did. So along with many discussions with the customer, the audit included meeting with the researcher who wrote the original application, just simply to learn more about what the application does and how it does it. And on the slide here is just a brief overview of that audit. And the audit was actually really enlightening because we discovered how many features the app actually had, and interestingly, that we weren't even using all of them in production. So, for example, there was this feature called content balancing. Now, what this means is if you have items from different topics in the same item bank, then you can make sure that an even number of questions from the same topic or category are shown to the student. So basically the model would determine what category needs to be shown next, and then of these items, which is the best match for the student's ability. However, in production, we actually had a separate item bank for each category. So we actually didn't need the content balancing feature. Now, the customer did express a desire for this functionality in the future. So what we did is we added as a potential requirement for a future release, but we deliberately left it out of version 1. And this phase of the project was quite interesting as we uncovered how powerful the original model was and how little of it we were utilising in production. Because had we uncovered all of these layers and learnt that we were indeed using all of them, then this would have been a really good moment to go back and consider whether, in fact, a rewrite was actually a good idea. Because do you remember point 3? The scope is small and well-defined. Well, that's not just something you think about up front. That's something you need to keep in your mind as you go. Because I think this is a huge trap for developers, especially if you've been on a project for like less than 12 months, so you've just joined it. And it's actually, to me, a little bit Dunning-Kruger. We start to understand just enough of the domain that we think, oh, why is this so complicated? If we could just start over and simplify the data model and then abstract that over there and use some newer technologies while we're at it, you know, we could move faster and enjoy working on this project much more in the process. But the truth of many production systems is that they are the way that they are for a reason. You are not smarter or more insightful than your predecessors. Sure, things do evolve over time, and decisions made in the past might be suboptimal given today's context, but often there is so much more to architectural design decisions than what is immediately apparent. So I would say that if you do decide to pursue a rewrite, even if you are already writing code, treat the first phase as a discovery and feasibility phase. And you've got to prepare yourself mentally to walk away if things turn out bigger and more complex than you expected. So after a few meetings, we had an overview of the features and requirements for version 1. And it was decided that the system as a whole would be a drop-in replacement for the old system, but the underlying statistical models would in fact change. And this was for a couple of reasons, but the main one was to make the model extensible in the future. So the current model, or the old model, only used one quality, item quality or parameter to estimate the student's ability. So that's the item difficulty. However, under item response theory, there are at least 2 other parameters that can be used. And the other key reason for the change in models was, as mentioned, that there were just so many features that weren't being used at all. So the combination of unused features plus the desire for future extensibility led the researchers at the customer to decide to actually rewrite the underlying statistical models as well. And that approach did impact that decision did impact our approach to testing a little bit. So in the end, it was the role of the researchers to validate their new model against the old service, and they provided us simply with just a list of inputs and a list of expected outputs, and we just added that to the test suite. And overall, it was actually a really nice collaboration as we both analysed the existing application code from different perspectives. So at Trifork, we looked through the lens of inputs, outputs, exception handling, and edge cases, whereas the researchers were more concerned with the mathematical methods and the psychometric validity of the model. So when we at Trifork were ready to start development on the application itself, we were provided a model from the researchers that was written in R and accompanied by mathematical notation. So that meant that the team members could work on understanding the model in a way that was most natural to them. So personally, I preferred the mathematical notation. It was a lot more natural for me and helped me figure out the R code. However, for some of my colleagues, the opposite was true. They preferred the R code over the mathematical notation. And I want to clarify here that when I say we were handed a model, really it happened in stages. It wasn't like the researchers sat in a room for 6 months and then went, here, put this in production, please. The researchers were fully aware and on board with the fact that we planned to use Kotlin, and they even did their own investigation of libraries that were available and discussed them with us. I mean, there's an advantage to working with PhDs. Now, as for the reason that we chose Kotlin for the project to begin with, I do hope you already have a little bit of an idea of the reason as to why. So as I mentioned, Trifork Amsterdam is a Java Kotlin Spring shop. It's our bread and butter. It's what we do. In my team in particular, we have a strong preference for Kotlin. Believe it or not, I actually learnt to program in Kotlin. Now, in my opinion, choosing Kotlin or Java in the context of a Spring Boot application is really little more than a preference. Sure, your preference is wrong if you choose Java, but everyone's entitled to their own mistakes. As for the choice of Spring Boot, the downsides of the framework, such as the size and the startup time, they were going to be a non-issue for us. We just keep this thing running. It's a good enough choice in the context of our company and our team. So having made our language choice of Kotlin, and together with the researchers, we looked at the numerical packages available to see whether they would be a good fit for building the model. Now, JetBrains have been pushing data science for Kotlin for years now, so we knew that there was plenty out there. And two options that came up during our search were multi-K and SMILE. So multi-K is a multi-dimensional array library, and SMILE stands for Statistical Machine Intelligence and Learning Engine. Now, immediately, SMILE just seemed way too overpowered for what we were doing. However, multi-K was a solid candidate. So at Trifork, we went back and we did some small experiments. And what we found was that while multi-K would do a fine job, it didn't add anything extra for our use case. It did make light work of calculations on multi-dimensional arrays, which we would certainly be doing. But after a bit more consultation with the researchers, we found out that the arrays in the final model would actually only be two-dimensional. And this was a very, very important distinction because two-dimensional space is pretty straightforward. 3+ is where it starts to get tricky. Because another way to think of a two-dimensional array is just as a list of multi-parameter objects. I'll show you what I mean by going through an example in the next few slides. Then after that, we're actually going to nerd out on some mathematics, on a concept many of you have probably forgotten, or perhaps deliberately. But don't worry, I will keep it light, I promise. And this discussion is nice to have because it'll just give us a little bit more context on the reasons why we chose the tech stack that we did. So we're diving into the example now. So in Kotlin, we can simply define a data class of multiple primitive types. Now, this is a trivial example using waffle sales at a waffle store, just to keep the domain as simple as possible. The very first time that I did give this talk, it was in Belgium, so it has to be waffles. I was going to change it for a local audience, but who doesn't love a good waffle? So let's say that you have two kinds of waffles for sale at your waffle store. Stroop, which is the Dutch one, and Belgian. And they're each for sale at a different price. So Stroop waffles are €2 each, and the Belgian waffles are €3 each. The Belgian waffles naturally being more expensive because they are more delicious than the Dutch Stroop waffles. And I know I'm being a traitor to my adopted country. Please don't tell them. I want them to let me back in. Now, after you have the data for each of your products, you can then define the weekend sales data of your waffle store as a list. Now, to upgrade this code a little bit, you can actually lean into the type system and define separate types for the quantity sold on each day of the week, for example. And we use this pattern quite a lot. It means that you never confuse the sales for Saturday with the sales for Sunday during your calculations, as they are different types. The compiler will tell you right away if you try to use a Saturday value where you should be using a Sunday value. Now here, the distinction doesn't really matter because the price is the same on both days. But this extra bit of type safety actually saved our butts quite a few times. To give you, though, a little bit more of a concrete example, so in our model, item difficulty and item discrimination are both doubles, and they're used side by side in the code base to determine which item is the best fit for the student at a certain point in an assessment. So by declaring them as separate types, we can be confident that when we're doing the calculations on the intended parameter and not the wrong one, and this can help us prevent erroneous results, actually also reduced the number of test cases that we needed to write. Now, back to our waffle example here, and continuing on, you can calculate then the daily sales of your waffle store by using the syntactically beautiful sum of function. And you end up with €105 of sales on Saturday and 94 on Sunday. Now, just for a quick comparison, let's have a look how you would represent this calculation with the multi-K library. So the cool thing about multi-K is that it allows us to use matrix notation, so to speak the same language as the researchers. So we can represent the waffle store data first by declaring the prices of the different kinds of waffles in a 1x2 matrix, and then we can declare the daily sales in a 2x2. And so on Sunday, we sold 15 stroop waffles and 25 Belgian, and on Sunday, we sold 20 stroop waffles and 18 Belgian waffles. And then we get what's called the dot product of the prices and the quantities, multiplying the row of the prices matrix by the columns of the quantity matrix, and then adding the results together. And by doing that, we come out with the same result as the previous method. So 105 euros of sales on Saturday and 94 on Sunday. Now, you might have a different preference, but for our team, using the features of the collections library on a list of type-safe objects, as we saw on the previous slides, was much more natural for us than manipulating two-dimensional arrays or matrices, as you see here. And sure, this is a lot more lines of code, but it is more readable, and it actually trends towards self-documenting. So it actually turned out that we could do everything with the Kotlin standard library, and the researchers' model was written in R with that in mind. They still use two-dimensional arrays or matrices in their models, but we could easily rewrite those as lists of multi-parameter objects. And the experiences that we gained with our experiments with multi-K actually helped us a lot there. And I want to move on to the last section of the super nerd segment, which is the calculations themselves. So knowing that we wanted to stick with the Kotlin standard library when formulating the model, the researchers stuck to approaches that relied on basic scientific methods. So in the end, there was nothing more scary than Euler's number and the natural logarithms. And the Kotlin math package actually has us covered there. So just as like a quick example and a little refresher, so this might be your first time seeing it maybe, no problem at all. As I said, I'll keep it light, but I did promise a little bit of geek in the abstract, so let's do it. So as I mentioned, this conversation just provides a little bit more context to our tech choice. So this is Euler's number E, and it's a base rate of growth shared by many continually growing processes. And this gives it a central role in many domains, from investing to probability and to radioactive decay. So just like pi, it is an irrational number with a set value. Now, what do I mean by that? Well, in mathematics, irrational means that there's no limit to the number of decimal places that it has, and there is no repeating pattern in its numerical value. So here to make it a bit more concrete, I've written it out to 150 decimal places. I hope that the first three look familiar to a lot of you. The other cool thing about E is that it is its own derivative. So the gradient function of E actually is the function of E. And that's not pointless trivia. That's actually an important property that we exploited in our model. And we're going to go one level deeper now. The value of E is the limit of the following expression. So if you keep adding these fractions together, as n approaches infinity, you actually get closer and closer to the true value of E. And now the last little bit of tidbit of trivia before we move on. So given the exponential properties of E, Euler used the letter E simply to refer to exponents, but like by one of those cool coincidences, like how Thomas Crapper is known for his work on toilet-related patents, the letter is now just associated with his name, E for Euler. And in terms of working with E in code, in most worthwhile languages, yes, even though I'm a Java developer, I would consider C# a worthwhile language, you get a convenient exp, which is e to the power of the past value. So exp3, e to the power of 3 equals 20.08, and you also get the natural log function, which is the inverse of the growth function. So the natural log of e to power is approximately equal to 3, and this inverse relationship is another useful property that we could exploit in our model. So these two functions, combined with other basic stuff like the power of, the absolute value of, and the square root of, ended up being the core of our model. So while the maths involved was far from straightforward, the researchers were able to come up with a valid solution using pretty straightforward mathematical expressions. And this meant that we could write the core model in a pretty clear and maintainable way with just the standard library, which I actually think is pretty cool. Maybe I'm just a big nerd, but I think that's pretty cool. And it also validated our choice to pick the tech stack based on what was good enough in the context of our team, rather than trying to find the best language packages for modeling item response theory, because they do exist. So I'm going to pivot pretty hard now. It's the last thing that I promised in the abstract. So if you did read the abstract, we're on track. You're probably going to get a bit of a shock when you see the slide, but I promise that it will make sense, okay? So I'm going to use the last part of this talk to shamelessly throw in some pictures of a cute dog, because I really want those good ratings, while I reflect on taking my first steps into a leadership role as a junior developer. Now, one of the things I really like about working at Trifork Amsterdam is that we don't really have fixed roles or titles enforced. We like to focus on the individual, and if there's an opportunity that comes up that matches your skills or desires, like, have at it. So even though I only had a couple of years of experience as a developer when this project came up, I ended up taking a leadership role in some areas. And spoiler alert, it had mixed results. So in my studies of civil engineering and economics, I actually did quite a bit of calculus and linear algebra, and I had some experience with packages like MATLAB and Mathematica. And I am by no means a mathematical wizard, not at all, but it is a solid enough background, and it was, at the time, the most maths experience in the team. And if you add to that I'd been working with the customer for about 2 years, my domain knowledge was pretty solid as well. So the planets had seemed to align for me. Now, having suffered mega imposter syndrome for the last 2 years, mostly fueled by insecurities related to not having a computer science degree, I jumped at the chance to show off these different skills that I had picked up along my unconventional path to becoming a developer. And I came to those first meetings with much enthusiasm and lots of questions. So what model do you want to use? Where do we get this number from? How do we go about solving for that parameter? Do you have a paper I could read? And to be honest, I was probably quite insufferable, but just like an excitable puppy accidentally knocking over a pot plant with a stick that's much too large for her, I got a bit of a free pass, and most of my questions were answered. And even though I didn't understand all of the answers all the way through, that didn't matter. I could get my head around the basics. We had a probability function that we couldn't solve directly, but we could estimate it iteratively using the boundary closure approach. And as I already mentioned, the customer was kind enough to provide a working example in R. Now, R is not a language that I know well, but given enough time and Googling, I could figure it out. I also had access to the service that we were replacing. Again, not a C++ developer, but by taking my time and annotating as I went, I could understand it enough to ask the right questions, get the right feedback, and form a sound understanding of the domain. And it was pure joy for me figuring out how to turn mathematical formulas and R scripts into production-ready code. The kind of joy that you see on a dog when she plays with her favorite ball. And we're a small team. So in the beginning, it was largely my task to put the proof of concept together. And that worked for a while, until it didn't. I was having so much fun that I just didn't include as many people as I should have as early as I should. Don't get me wrong, the project was absolutely a team effort, but the proof of concept of the core model was a pretty important chunk of the work, and I kept too much of that chunk to myself early on. And I had documented some stuff, but I hadn't documented all the loose ends that I still had in my head, all the stuff that had to happen before we went to production. And it was summer by now, so like a good little European, I went on holiday. And I'm a firm believer that timing is everything in life. So you guessed it, while I was on holiday, the external pressure started ramping up, pushing us to get the first deployable chunk into production as soon as possible. And all of those to-dos that were in my head were still in my head, and only in my head, on a beach in Greece. And I came back to work, and it had been a chaotic 2 weeks, apparently. And the worst part was some of the main issues that the team faced were like non-issues to me. I felt awful, like, sorry guys. So yeah, that was a really big lesson for me. Leadership is much more than knowing what's going on and making yourself available to answer questions. I don't like to assume that others don't know things. I know that my colleagues are smart as hell, and I don't want them to feel any other way. And I think this comes from my own feelings about my intelligence and my identity, that if I'm not smart, then who am I? But that philosophy is ultimately unhelpful, and it's unfair to others, because if people get offended because you want to keep track of the details just for the good of the team, then that's on them. So definitely, if I had my time over, I would be more proactive in keeping the lines of communication open within the team and set an example by documenting everything as I went, even if it's just brain dumping in a ticket. As my Uncle Fred would say, better out than in. And one final note on this, because I think it's really important for you to hear, even if it's just from some rando on stage. You know, even though I did make some mistakes in my first toe dip into leadership, I am happy that I did it. I learned a big lesson, and it's been invaluable to me as I organically take on more leadership responsibilities as I progress in my career. So I want to make sure that you hear that message, that if an opportunity comes up to extend yourself a little bit, you know, what are some qualities or experiences that make you a good fit, even if you don't have any direct experience in that exact task? And who can you ask for support, either inside your team or within it? And speaking from my own experience, imposter syndrome never goes away, but you do get better at shutting it up. And the way you get better is proving to yourself that not only can you do hard things, but that you can dust yourself off and try again if things don't go according to plan. So, to wrap up, let's revisit the title of this talk. Are rewrites always a bad idea? Yell out what you think. Come on, don't be shy. Yeah, well, I set you up, of course, because purely just based on the way I've posed the question, the answer has to be no, simply because there are no certainties in life. Sweeping generalizations are always wrong at least some of the time. Now, maybe a better question is, are rewrites generally a bad idea? And here I can give a resounding yes, but they can be a good idea sometimes. So in this talk, I provided you with the top reasons to entertain the idea of a rewrite. And ideally, all of them would apply to your rewrite candidate, but personally, I would like to see reason 0 and at least 2 others. So reason 0, so called because without this one, all others are irrelevant. There is a desire to functionally change the application. So if you're not touching the application in any way and it's running reliably and securely in production, why does it need to be rewritten? On to reason 1. There are no small steps to be found. So you've determined the application does require some ongoing development, but the code base is in a state and there are no quick wins for your team to start improving it. Reason 2, the skills are not in the team and you do not wish to acquire them. So in other words, improving the application requires a steep learning curve towards skills and knowledge that the company does not need or does not want. 3, the service is small and the scope well defined, or it can be broken up in such a way that this is true. So this means that you can deliver value and get buy-in early, and the potential downside is small. Now, if, despite the odds, you have determined that your application is indeed a good candidate for a rewrite, then you can take small steps towards that goal. So start by conducting a thorough audit of what the current application does and what you'll be rewriting. Keep it small and specific with a healthy air of skepticism. Stay humble while you do this. The app is the way that it is for a reason, so be curious, not judgmental. Treat the audit as a feasibility study. If there is more scope or complexity than you first envisaged, be prepared to label the project as not feasible and walk away. Yes, even if you have already started writing code. Now, in our case, the application was more complex than we first thought, but a lot of that complexity was in unused features. And the audit helped us make sense of this and get us to a bare bones 0.9 version implementation. Now, when it comes to the tech stack, make a good enough choice within the context of your company and team. Rewriting an application comes with enough risk as it is. Adding a new or unfamiliar technology to the mix is just adding another layer when things can go wrong. Add value to your stakeholders as early as possible. Don't be afraid to experiment. For example, scope out a functional spike related to a pain point of your users. Put it in their hands. What do they think? And lastly, don't be afraid to step up and do something scary. I can't promise you that it will work out the way that you wanted, but I can promise you that you will learn something about yourself. My name is Adele, and thank you so much for your time.